In 802.11 AH, which is the IoT 802.11 for IoT, everything is shortened. They want number of bits to be less and the speed to be less so that the distance can be large, right? And the number of stations also they want large. So to increase the number of stations to 8,000, obviously you didn't want to treat all 8,000 as the same. If you use all 8,000 as the same, you need 8,000 bits in the beacon to tell, whose turn is what, right? Whose packets are waiting. So they said we cannot do that, and we will just do it for 2,000, which was originally in the other 802.11 standard. So they broke it into 8 pages, and so then and the pages are also broken into blocks and sub-blocks and stations. And so basically, instead of treating the whole thing equally, they just put into what we call segments. And segments is different from pages. Segments is any subgroup. So we could, for example, make this as 3 segments, even if I have 1 page. Okay? And segments, you make it by making blocks and sub-blocks. And then when you contend for a slot, they might reserve a slot for you, but not just for you, but for the whole segment. That way, only 8 or 9 people will contend for that particular slot and not 8,000, like in the original standard, or 2,000 in the original standard. Okay? So that way, the efficiency goes up for a large number of stations. The restricted access window is exactly that, is a slot which is reserved for a group of stations. So there are a whole set of slots, and each slot is reserved for a group. In that way, it reduces the contention. A TIM station, and TIM was that time indication map. TIM station can be allocated slots during restricted access window RA to transmit or receive the packets, right? And RA is this restricted access window. RA is a part of the contention-free period. So in 802.11, we had contention-free, which is reserved, and contention-based, right? In the original standard, contention-free was just reserved for 1 station, right? Now here it is for a group of stations. Access may be granted for transmission, reception, polling, etc. to 1 or a group of stations. A RA schedule is transmitted at the beginning of the RA interval. So whenever the RA begins, first few slots will tell you what the rest of the map is. Map means, which group for what. A station can tell access point if it has frame to transmit using an UDI indication bit. So basically, the way a station has a slot, let's say slot number 5 is yours. In that 5, you cannot transmit too much. Slot is very small, right? But you can send a small frame, and you can put the UDI bit in that one up. Once that bit is up, then the access point knows that you have something to transmit. Okay? And it will give you a better scheduling next time. So transmit using UDI bit, and dividing stations into groups and dividing times into slots for each group increases the efficiency under heavy load. And last time we had discussed that fully reserved is good for heavy load, and fully random is good for light load. Okay? I mean, even for the traffic lights. When you are standing at the traffic light, if there is no traffic, you feel, why did they put the traffic light here? So if there is no traffic light is good. Randomly people come and go, right? If 5 o'clock, you cannot do random. And there is traffic, you need to reserve time. So that's what it is that dividing stations into groups and dividing the time into slots, and then each group has a smaller number of slots, gives efficiency close to 100% at 100% load. And regular EDACF will give you 0% at that load. Nobody will succeed. If there are 8,000 stations, you can keep, extending your collision window, and you won't succeed. Now, this is another one of those little things that, sounds so simple, but was not used in any of the protocols before. So now that we have discovered it, it will be used in all of the protocols from now on. Okay, so there are not just 2 extremes, contention-free and contention period, right? There is in between where there is contention, but only a small number of people. Well, similar things are used for other things. Periodic RA, period and duration of the RA are announced. Periodic RA is for periodic stations. Sounding RA for sector sounding to figure out how many sectors you have and how many sectors I have. Remember, we did it for 802.AD, 11AD, where we figured out that you have 3 sectors and I have 4 sectors, and my 3rd sector aligns with your 4th sector. So that is called sector sounding. AP power management RA to announce when it will be sleeping. So it will say that is restricted access during this period, I'm gone. Non-TIM RA. So the stations which are not TIM, there were 3 kinds of stations if you remember. TIM stations. Then there were stations that were periodic, and third that were totally random. Totally randoms are the one which will come up once a week or once a day or something, very rarely, right? So non-TIM, the last 2 categories are non-TIM. And then triggering frame RA allows stations to send PS pole frames, indicating their need to transmit. So PS pole is basically power save pole. Is that I was sleeping, now I'm up, can I send? Right, you send this to, and similarly there is another pole which is every beacon, the access point announces that I have is frames for 5, 3, and 2, whatever. And then when you hear that, then you say, okay, all right, I am up. Please give me that station. They may announce 1,000 times, and after 1,000 times you hear it, right? So then you say, okay, I'm up now. Give it to me. So that's another kind of pole, PS pole. But here PS pole is used to indicate your need to transmit. You can also indicate your need to receive. You're up to receive. So these are all reserved periods. Basically what it is that now CFP, the contention-free period, has many applications, and 5 of these are listed here. One we saw before, which was just for TIM station transmit. For the stations which are not TIM, which wake up after a day or whenever they want to wake up, they have a target wake up time. So they say, well, I might sleep for some time. Now the time could be very large. So instead of specifying the time as how many seconds are going to sleep, you specify the power, mantissa. Okay, so you specify like 3.2 times 10 raised to 15, something like that. So you specify the mantissa. So that is basically specifying in log scale plus the thing is, right? So you can specify a very large range. So you specify your wake up interval mantissa, and then they will not bother you for a day. I mean, whatever time you have specified, and then when your time is for you to wake up, then they will start announcing that I have a frame for you. Otherwise, there is no point in the access point announcing every second, and you are going to wake up in a day. So now you can sleep for long. Even the access point can sleep. And when the access point wakes up, they know when you are going to wake up, just near your wake up time, it will start announcing that I have frame for you. And then you can send that PS pole to get that. Target wake up time can be very large. So what this picture tries to show is that in 11AH, there are 2 stations. They have a different times to wake up. And the access point has its own time to wake up. So, of course, if you're going to wake up every day and the access point is going to wake up every hour, so there will be 59 minutes when there's nothing can be done because everybody is sleeping, right? When the access point comes up every hour, and then it says, oh yeah, this guy had said he will wake up in 24 hours. Time for him to wake up. So then it will send out the beacon, and then they will do. So they will become active. So these active times, could be rare and could be somewhat consolidated around the target wake up time. Now this is going to be basically very different than Bluetooth and Zigbee and other protocols that we have seen. So I have very high hope for this. Now this is all theory right now. This is all theory because there are no products doing 11AH. Right? The standard is still on the draft 5 as I told you last time, right? But that's it. Authentication. So basically, new mechanisms to allow authenticate a large number of stations. So centralized authentication. Basically, if 8,000 stations are going to come up, how are we going to authenticate? So that for that they have again put people into ranges. If you are between this and that, then please come and register. And then if you are between that range, that range, that range, so that way we can see, right? And for authentication, of course, there is a contention. Even for this 0 to 1022, there is a contention, and so there is exponential back off as usual. And I would not be surprised, I'm not saying this on this slide, but that there is a trust center somewhere in the back. Trust center does not have to be in the access point in particular, because the access point is much more open. Anybody can steal the whole access point. So generally the trust center is separate, somewhere logged in a key, somewhere inside a locked door. Okay, that is where the authentication will happen. The main new stuff here is that for authentication, there is a backoff. And group sectorization is that access point generally could have many sectors, and each station will be told what sector they belong to, and then the stations will be told when they can transmit in each sector. Okay, so this is basically, remember what this is called. This is called not home area network. What is it called? So the neighborhood area network basically means that it is covering a mile of neighborhood, right? So there could be a lot of devices, lot of meters to read that this will be used for, right? So that's why they have sectors and things like that, and so on and so forth. That brings us to the end of AH. It runs at 900 megahertz, and you know why at 900 and not at 2.4? Because 900 goes much farther, right? At least 3 times longer, if not more. And they didn't have to invent a new phi for it. They just took 11 AC and clocked it down by 10x. What does that mean? So the time domain duration is 10 times. Frequency domain, it is 1/10. So longer symbols, longer multipath. So now you can go longer distance. MAC is more efficient by eliminating or reducing the header. Header was 12 to 26 bytes shorter. Aggregating ACKs. You didn't have to ACK every packet. Null data packet. Everybody remembers null data packet? What does that mean? 0 byte MAC layer. Everything is phi. Okay. Null data packet. Speed frame exchanges means many frames in a burst. You can just send. And you can receive and send and receive and send. So exchange. Saves energy by allowing stations and access point to sleep. Longer sleep using the target wake up time and restricted access window. Okay. So those are all the new stuff in 11AH. Yeah.
Can I ask a question about authentication? The authentication, you said that the access point announces the threshold and the beacon. What?
No, slowly. Access point is what?
Announces a threshold in the beacon.
You want me to go back to the slide?
Yes. So I was wondering how much is a threshold? Like.
Okay, numbers. Okay, hold on. Let's say I have 13 people here and I want to authenticate. I could say first 5. Okay, 6 through 10, and then 11 through 15. Threshold is simply the range.
I know, yeah. I mean, like the huge number of stations would be like authenticated, or it's just a small group of.
No, one by one. Everyone has to be authenticated. Yeah, I can't authenticate 5 at the same time. Right? But the thing is, I don't want to authenticate 15 at the same time, so I divide into a small group and say, okay, all right, in the next 1 minute, let's do 5. Okay, so these guys will remain quiet. And then next minute, these, this and that, right? So just dividing them into ranges. So there is not too much contention. Otherwise, you won't get past authentication, let alone operation.